Hi, welcome to Old School Chemistry. We are going to do a neutralization reaction and look at the specific heat, a change in temperature dealing with energy. This is from the G main exam, August 27th, 2021, the 9 a.m. to 12 o'clock test. This question 10, let's go ahead and read the prompt. So it says 200 mils of 0.2 molar HCl is mixed with 400 mils of a 0.1 molar sodium hydroxide. Then find the change of temperature given, and they give us three pieces of information. The heat of neutralization for 1 mole of HCl and 1 mole of the sodium hydroxide is 57.1 kilojoules per mole. Notice that unit, we've got kilojoules and moles, okay, mental note. They give us a specific heat of water is 4.18 joules divided by gram times degree C, and the density of water is 1 gram per centimeter cubed. So there are three steps that we're going to walk in this. The first one is I want to just digest what's happening with this neutralization reaction. I'm wondering, is there a limiting reactant? I want to look at moles because I saw mole right here. So let's look at this reaction. We have the HCl plus NaOH is going to produce sodium chloride and water. I want to look at amounts to do initial final amount and see what reacts and what's left. So we have the 0.2 liters of the HCl. I just took 200 mils, converted that to liters, times the molarity, 0.1 mole divided by liter gives me 0.04 moles of HCl that are available to react. And then we'll take the NaOH. We had, I just mixed these up. We had 400 mils, so that's going to be 0.4 liters with a 0.1 molar solution. There we go. So we multiply by 0.1 mole over liter, and that gives us 0.04 moles of sodium hydroxide. So we begin with initially 0.04 moles of HCl NaOH. Of course, no sodium chloride has been produced, and water is going to be negligible because it's the liquid phase. And then when this reacts, look at it. Wow, it's in perfect stoichiometric ratio. So we'll have 0 of each of the reactants left. They will both be completely consumed, and we'll just have that sodium chloride that's produced. And remember, those both produce, or both of those ions are spectator ions, they're neutral ions, that they won't impact pH at all, just as a little side note. Okay, so with that in my mind, I then go to step 2, and I want to start thinking out this specific heat they had given me. They give me energy, and so I know that we're going to use our formula, Q equals Cm delta T. They want change in temperature. That's what we're looking for, and they give me, in one way or another, the rest of the information. So I want to find delta T. That means that you and I have to figure out, well, what's Q, our heat, our energy, C, the specific heat, and M, the mass. So C, that was easy. They gave that to us. 4.184 joules divided by gram times degree C. Now the Q takes just a little bit more work. What they gave us up here, notice that unit, kilojoules per mole, that is delta H. That's your enthalpy, that heat of neutralization. So if I take my delta H, I just want energy, joules. I've got to get rid of those moles. So first thing that I did, I took the 57.1, went from kilojoules, 1 kilojoule to 1,000 joules, and then I have to get rid of the moles. Here's where we're going to come back and reference this. Well, how many moles reacted to produce this? Notice it's a 1-to-1 mole ratio, and so 0.04 moles reacted, which produced over here the 0.04 moles. So what I put here is the 0.04 moles, So when we multiply this, the Q comes out to be 2,284 joules. In this very unique situation, when I have my 0.1 mole, or my 1 mole and my 1 mole, okay? And notice this is a 1-to-1 ratio there. We're going to have the 2,284. Another way to think about this, notice that ratio 1-to-1, and sure enough, they gave us a 1-to-1. We had to multiply it by the 0.04 because this number, the 57, is when you have 1 mole of each. Well, we don't have 1 mole of each. We have 0.04 moles of each. So we multiply by that to get just the fraction, the amount of energy that will be released in this unique situation. Nice. So we found Q. Nice. Now for M, mass. They gave us density that the solution 1 gram per 1 mil. Actually, we can use this density of water for our solutions. So if I take my 400 mils and my 200 mils, that gives us a total of 600 mils. Together, our 600 mils, we can use the density. 1 mil is the same thing as 1 gram, so we've got our mass, which is 600 grams. Hey, you guys, come have a seat. So our third step is just plug and chug, put it all together. So I put my Q, 2,284, there's my C, my mass, and we just solve for that delta T. Small number. Notice the delta T is 0.9098. They had given us just 1 sig fig on those molarities, and so we'll report it to 1 sig fig, which the change in temperature is going to be 1 degree C. Wow, good work. Notice I have a couple of cards up above. If you need a little more help and explanation, you can take a look at those videos. Thanks for being here. Good luck on your test.